Hi, this is Yogesh Langre. In this video, we will see a numerical based on the force convection. A statement of air at 20 degrees Celsius flows over a plate of 60 centimeter by 30 centimeter with a velocity of 29 meters per second. The critical Reynolds number is 5 into 10 to the power 5. Calculate the heat flow per hour from the surface of the plate as a flow is parallel to 60 centimeter side. Temperature of the plate is 100 degrees Celsius. The properties of air at a mean temperature is given. Density of air is 1.06 kg per meter cube. Specific heat of air is 0.24 kilocalorie per kg per degree Celsius. Kinematic viscosity of air is 18.97 10 to the power 6 meters square per hour. And thermal conductivity of air is 0.025 kilocalorie per hour per degree Celsius. So here we need to calculate what is the heat flow per hour. So this is our aim to calculate. And for that one, let's on the basis of the data which is given, we try to calculate the rate of heat transport, that is Q. Okay. So here the statement in this one, it is mentioned the density is given. So this is the density. This is the specific heat. Okay. The kinematic viscosity is given. Here we are not given the dynamic viscosity, and the thermal conductivity is given. Okay. So first we will write all this data which we show. Apart from this one, the data with us is the air temperature. So temperature of air is 20 degrees Celsius. And also we have the plate temperature is mentioned here. It is the plate temperature 100. So temperature of plate on which the heat is flowing is 100 degree Celsius. So with the help of these two, we can calculate the temperature difference, which is the delta T. Okay, so later one we will calculate it. After that one, we have the dimensions of plate. So what is the dimension? It is 60 by 30 centimeters. So we have the dimension. So from that one, we can calculate the area which is required. It is the length into the height. So we can say 60 multiplied by 30. So as it is in a centimeter, so we will convert into the meter as all the other readings are in units are in meeting. So it is 0.6 multiplied by 0.3. Whatever be the result, that will be the area. Okay. So later we will calculate what is the area of it. Now, in this numerical, another term is given to us, which is the velocity. So velocity is given, we we can say 29 per meter second, and the Reynolds number is given. Reynolds number, which is of 5 into 10 raised to the power 5. Okay, so with this data, with the given properties of air, okay, as well as this one, we try to get the values of others. So let's see how we can calculate the Q. To calculate the Q, what we need to calculate the Q, we have the formula, and the formula is as Q is equals to the H A delta T. So if we know the value of H, okay, if we know the value of H, A and delta T, we can easily calculate this one. So as the area, we can have that value 60 by 30. Temperature difference also with us, but we do not know the value of H. So for that one, we need to calculate H. How we can calculate the H? We can calculate the H if we know the Nusselt number. So Nusselt number is what? It is H, the transport coefficient into the L upon the conductivity of the fluid. So here again we don't know the Nusselt number. Now to calculate the Nusselt number, what we have to do? We have to use the correlation. So what is the correlation for the force convection and for say average heat transfer coefficient if you want to calculate? Then we have a formula. The Nusselt number is equals to the 0.664 into the Reynolds number raised to the power 1 by 2 and the Prandtl number raised to the power 1 by 3. Okay. Now, with the help of this formula, I can easily calculate the Nusselt number. So here again, we know the value of R, it is mentioned, but we don't know the value of Prandtl number. That is not mentioned. So here, again, we try to know what is the Prandtl number, and we know that it is a dimensionless number, and the Prandtl number is equals to the Cp, the specific heat, into the viscosity, that is the dynamic viscosity, upon the K, the conductivity of the fluid. Okay, here in our data, we have, just like in this data, we given the value of Cp, we know the value of K, but we don't know the value of viscosity. So here it is mentioned the which viscosity, it is here mentioned the kinematic viscosity, and in our formula we need a dynamic viscosity. Okay, so here we need a dynamic viscosity, and for that one, what we have to do, we need to calculate the dynamic viscosity. And for that one, what is the relation? The relation is that if I want to calculate this viscosity, then we know that mu is equals to the mu upon rho. Now here we know the value of mu, kinematic viscosity, as well as we know the value of density. So with the help of this one, I can easily get a value of mu, which is mu into the rho. And both the values are mentioned in the data. Okay, so here, if I do the reverse case, then viscosity known to me, I put it the value of viscosity here. I get the value of Prandtl number, I put it the Prandtl number, Reynolds number with me. I get a Nusselt number here. Once I know the Nusselt number, then what I have to do, I just have to put it this Nusselt number correlation here, and from that one I can easily get a value of H. When I put it this value here, I can get a value of H. Okay, so step by step we will use these formulas, and from with the help of these formulas, we try to know what is the Q value. So here what we have to do, let's let's calculate. So here we can calculate first the area. Okay, so area that is known to me, area is 60 by 30. So 60 by 30. So I converted this into the zero point 0.6 into the zero point 0.3. Okay, this is in meter, and yes, I just put it as it is, no problem to me. This value, okay, which is 0.18 meter square, but don't need to do this. Okay, just put it as it is, no problem. Well, and delta T. So we can calculate the delta T as I mentioned in the first case, that here we can calculate this delta T. We can calculate this delta T with the help of these two temperatures, the temperature of the plate and temperature of the air. So here we can do these calculations. So what is the temperature of plate? So the temperature of plate, which is T plate minus temperature of air. Okay, so temperature of plate, which is mentioned, is 100 in minus the temperature of the air, which is 20. So it is comes to the 80 degrees Celsius. Okay. Now, with the help of the formula, as I said, Q is equal to H A delta T. So these two values we calculate. Now we will focus on H, and for that one, we have first to use the correlation, and we use the correlation at the Nusselt number. So we use the correlation to get the value of H. To know H, we first calculate Nusselt number. So we use the correlation. Nusselt number is equals to the 0.664 into Reynolds number raised to the power 1 by 2 and a Prandtl number raised to the power 1 by 3. Okay, so here first we try to calculate the Prandtl number because that is not known to me. So we calculate the Prandtl number, which is Cp mu by K. I again repeated this to mu calculations. What we have the formula for the mu is equals to the mu divided by rho. So here we put Cp value. What is the value of Cp? which is mentioned it is 0.024. So I use, okay. So first we try to calculate the viscosity. So viscosity is equal to the nu into the rho. So value of nu is 18 into 18.97, sorry. Okay, it's 18.97 into 10 raised to the power 6 multiplied by the density, which is 1.06. So value of mu which we can get is about 2.01 doing this calculation into 10 raised to the power minus 5, and the unit is kg per meter per hour. Okay, so we get the value of viscosity. Now we need to calculate the Prandtl number. So it is very easy to us to calculate the Prandtl number. So Prandtl number is equals to the specific heat, okay, into the viscosity and into the upon the K. So specific heat which is mentioned, and the value of specific is 0.024. So I took 0.024 into the value of this one, which is the value of viscosity, which we already calculate with the help of this kinematic viscosity, which is 2.01 into 10 raised to the power minus 5 upon the conductivity of fluid. So here we have taken the conductivity of fluid, and the conductivity of the fluid is of 0.025, which is mentioned in the data. And from that one, we get a value of Prandtl number, and we got this value is around 1.93 into 10 raised to the power minus 4. Okay. So this is the value of the Prandtl number. So we got a value of Prandtl number. Now what we have to do, we just put it the value of Reynolds number as well as the Prandtl number in this equation. So what we have to do, I again repeat it, that part, that we have to take this to calculate Nusselt number. For that one, the Reynolds number is already given to me. Prandtl number value is from here. We need to put it here, and we get a value of Nusselt number with this fact. Okay, so let's do that part and calculate. Okay, so here we use the formula, that is the correlation. The Nusselt number is equals to the 0.664 into the Reynolds number. So what is the value of Reynolds number? Reynolds number is given 5 into 10 raised to the power 5 and whole raised to the power 1 by 2 into the Prandtl number which we have calculated, and the value is 1.93 into 10 raised to the power minus 4 whole raised to the power 1 by 3. So as per the correlation which we have, the Nusselt number is equals to the 0.664, okay, into the Reynolds number raised to the power 1 by 2 and Prandtl number raised to the power 1 by 3. So with this equation, we try to get the Nusselt number. So after doing the calculations of Nusselt number, so we got the value of Nusselt number is around 27.13. Now once we got the value of Nusselt number, we know the formula. Nusselt number is equals to the H, the transfer coefficient, into the L, into the conductivity. So here Nusselt number with us 27.13. So I just have 27.13 is equals to the H that I need to calculate. The value of L is given, which is zero point 0.6. So how we get a value of 6? It is that it is in mentioned in the numerical statement that the plate as flow is parallel to 60 centimeter side. So because of that one, the L length is taken, and that L length is here. It is 0.6 divided by the conductivity of the fluid, which is P here, the conductivity of the fluid, it is mentioned 0.025, 0.025, and from that one, we get a value of H, and the value of H that we got It is 1.13 and the unit is kilocalorie per meter square per hour degree Celsius. Now here we got a value of H. Now we have a simple formula with us to calculate the Q, which we have Q is equals to the H into A into the delta T. So already we calculate the A delta T and we have the value of H from this one. So put in all this value, H is 1.13, okay, into 1.13 into the A is zero point 0.6 by zero point 0.3 multiply by delta T, the temperature difference is 100 minus 20, that is 80. So already we calculate that one from the previous case. It's here, okay, itself delta T from here, area is from here. So with this one, we get a value of Q, and the value of Q, which is due to that after doing the calculations, we got a value of Q is equals to the 16.28 and the unit is kilocalorie per hour. So here, this is our answer that we can get a value of Q is this one, 16.28, and this is our final answer. So go with this step by step. So we'll get simply a value of heat, what we can say the heat flow per hour from the surface. The heat flow per hour from the surface, heat flow per hour from the surface is 16.28 kilocalorie per hour. Thank you.